This is Eric from Denaco Enterprise. I'm going to take you through Python for data science. This is the third lecture, and we are going to go through the last container, which was dictionaries, and also mention a few similarities between the containers and strings. So we saw that there are a few similarities between the containers and strings. For example, we can use the remove, we can use the indexing, we can slice using the indexing. So now we are going to talk about dictionaries. We start by printing our heading, or I can just use comments. Dictionaries. So dictionaries is a type of container whose objects have two attributes. Objects, normally we had lists which had objects with only one attribute. The attribute was value. So what list had was values of objects. But with dictionary we have two attributes. One of the attributes is the key or the identifier. The second attribute is the value. Let's create one dictionary and call it database. Okay. We use curly brackets to declare dictionaries. Curly brackets like we did with sets, curly brackets. So within the curly brackets, we add our first object. Our first object has a key and has a value. It has an identifier and it has a value. So the first object is name, that is its key, or that is its identifier. Its value, we separate the key and the value with a colon. A colon, not a semicolon, a colon, to show that the name key has the value, whatever we are going to put here. So we can use John. We separate our objects with commas. So we can have another object, and the second object can be identified as the age. Okay, the age has a value. The value is maybe 18. So John is 18 years old. We can add another object, and the other object can be identified as his height. So how tall is John? John can be 180 centimeters. Okay, now that's a dictionary. We can print the whole dictionary using the print function, the database, our name, the name of the dictionary. We can save. Let's save that as lecture 3. So this is the third lecture. Okay, lecture 3. Can save it there, save. Lecture 3. And we can try and run the module. So we can see it has printed our dictionary. So the first object is identified as a name and it has the value John. The second object is identified as the age and it has the value of 18, which is an integer, which is a number. The third object is identified as the height and has the value 180. Okay, we can carry on. We can, there are so many things we can do with the dictionary. We can access accessing what? Accessing an object. So we can specify that the object we want to access using its key or using its identifier. Let's try. We can print from the dictionary database whatever object is identified as age, for instance, let's see what it's going to print. So it prints 18, which is actually the value of whatever is the object that is identified as age. That is what we wanted. Let's see, what if I want to output more than one? Let's say we want to output his name and age. Name, and you can see yes, and let's try and run that. So that gives us an error. So the only way we can only output one object at a time. Okay, the value of one object at a time. Okay, now we can also have another function which uses a get function. The get function, it works pretty much the same as this one. Let's see how it works. We're going to print whatever is got from the database. So the database dot get, into brackets, we specify our key or our identifier, and see. Let's run the module. We can see it has managed to do the same. The main reason the only thing that can make us use get and not these other format is that get overlooks an error where whatever is the key of the object being sought is missing. If the object we are seeking is missing from our dictionary, get does not raise an alarm, does not raise an error, but this format actually does. Okay. We also want to see what if we want to add another, or do we want to add another object to the database? This was an assignment, but we are going to do it here. Access, okay, adding another object. So we do this by assigning a new object in assigning a new identifier a value. Let me just do it so we can understand what I'm trying to mean. Database. So we get a new identifier. So we assume that we want to we have a key going by maybe weight, and the weight is going to have the value 65 kgs, for instance, and we print our database, our dictionary, we save and we run that. We can run that and we are going to see that we have added a new object called weight. Similarly, we can edit the existing object the same. We can edit the existing object the same way. So let's try and edit the height, for instance. So we can edit the height maybe to, he cannot grow any shorter, so we are going to add, he can only grow taller. Save, and we try and run. We can see, sorry, we expect that let's print and check the changes. Print the database, and on running you can see that his height has changed. So that is how we edit values in a dictionary. Now let's try and remove the last object. Okay, this can be done by using pop. So we can database pop, and we can print it. Database. Let's try that. We expect to get rid of the last object. So this does not work. Okay, this does not work for dictionaries. So what we can do, we can try and use remove. Can try and remove the object weight, identified as weight, and see where remove works for database. Similarly, it does not. Okay, so these two functions do not work for dictionaries. How about we try delete? The delete function, you can try and delete database into square brackets. You specify that you want to delete whatever is called weight. Let's see whether it actually deletes. And it did. So the only way we can delete objects from our dictionary is using the del function or the delete function. Now that is all that was left on containers, that is as container dictionaries. There were some similarities when using strings. There were some similarities like indexing, trimming, and removing. So let's create a statement which is a string. Good evening, class. Let's start learning Python for data science. So this is a statement. Now we saw that we can use indexing as well as we can use indexing the same way we were doing for the containers for the list, and we can also use indexing to trim. We can use a range and trim the list, and we can also use a range to trim a string. Now there are also other functions that can work for string, and the same way we did for the list or the same way we did for the containers. One of them is remove. So statement dot remove. Let's remove, for instance, remove for instance the word class. Can even remove the space just before the word class, and let's print. If we print the statement, you can also print the statement before removing. And see and observe the changes. Okay, remove, sorry about that, not remove, we are going to delete, sorry, delete what? We delete from the statement. We want to delete a number of characters. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from 12, 14, 15, 16, 17, 18. So from 12 all the way to 18. That is what we want to delete. That is what we want to remove. And we can try and run that and see the same thing. Delete does not work for string. Okay. Let's first work with replace. We can replace that with a blank. So that would work for remove, and we can see that can replace class with, let's try something else. Let's try and replace it with all. You can add a space and see where it actually replaces. Now we have an issue. It still does not replace. It should replace. Don't know why it's not replacing. Statement dot replace. Let me try and get rid of that. And see, it still does not replace. Now why is that? Have I possibly misspelled the word class? No. Oh, can replace. Okay, let's try another function and see whether it works. Capitalize actually will capitalize the first letter and lower, and all the other letters will be lowercase. So it will lower the case of L and raise the, and G will be capitalized. So let's save and try running it. And is it like it's a problem with our system? Yes, I think it is an issue with the system. There's an issue with the system. Maybe you can call it statement 1. Maybe we have an issue because of the name we gave. Okay. Let's see. No, still nothing. Let's try and actually print that. Okay. So that should capitalize the first letter. Yes, it is. It capitalizes the first letter and lowers the case for the rest. That is what we expected. So we can try this for remove. Let's see whether we can remove. Something. We can remove class. Still an error. Let's see whether we can replace class with a space. Okay, let's run that and see what we get. Yes, it actually removed the name class. So we can replace whatever string we want with a null or with an empty, and actually remove it. We can also replace it with anything. We can replace class with all, for instance. So we can see that this one was good evening class, this one is good evening all. We can go to another function. So we have seen capitalize. Capitalize actually capitalize the first letter and the rest are left in lowercase. The next one is uppercase. We can convert the whole text or the whole string to uppercase using the upper function. Let's run that. Yes, we have managed to get the whole string in uppercase. We can do the same for lowercase. Okay, and we have lowercase. We can lower. Once you lower, you get the lowercase. Okay, so there we have every single letter is in lowercase. So that is all we have for the strings. Now we can start working with functions. Functions, in case we want to run the same operations a number of times, we can group them and make them a function which we can call at any point. So creating functions will require us to define them, then we give them a name. For instance, we can create a function to add, so it can be called addition. Then we give it parameter, then colon, and then we add a block of what we expect it to do. And we expect it to add. For instance, we have num1 is 4, num2 is 6. So we expect it to print the sum. So the sum is num1 plus num2. So we can call it from any point. So we just call it by typing in its name. And if it have parameters, we can input them here. Ours does not have parameters, so we can just leave it blank or void. So we can try and run that. So we expect to call the function which actually prints the sum of 4 and 6. Let's see. Yes, it has printed the sum of 4 and 6. But we can actually have parameters which can collect data from outside the function. We can actually run the function with our own data. So that would require us to add parameters. num1 and num2 would be parameters which we can input from outside the function. So we can form an addressation using 11 and 6. And this way, once we run, you can see, once we run, it still does the same. It adds 11 and 6. If we feed it with different parameters, maybe 10 and 6, we expect 16. It still prints that. But we can see that the print is the main function. So we can just require sometimes we might require a function to just add and output the sum, not necessarily print, but just give back the sum. So now we use return. So the result of running this function is return, is the sum. So this function will automatically give us the sum. So if now we want to print its outcome, now we print. We can use the results in any way. And we have addition, and we input our parameters. Our parameters can be 3 and 6. We expect it to output 9, to print 9. And let's see, it actually prints 9. So that is how we use the return. So the return, these just calling the function with the parameters actually gives the variable that is returned from the function. Now the function can have as many parameters as possible, and it's also very important to note the indentation. The block that contains what the function does actually is indented. They are not in the same level. If you want to symbolize that you have that is the end, now you take back your line to the normal starting point. You can see the indentation. If we want to add another block to the same function, we would make sure that it is indented. Anything that is not indented is not within the function. Now we have a different type of functions which is called the lambda functions. Lambda functions are simple functions that only have one operation. Like ours, we can only have the addition. Now they can only have one operation, but they can have a number of parameters. Let's create one. So we can call it summation, and we create by typing the name lambda. We give the two parameters num1 and num2. Then we use a colon to show now the operation. The operation is num1 plus num2. So there's a variable called summation that actually gets the sum of these two parameters. Now we can call this lambda function by let's print by just mentioning the variable summation. Then into brackets we input our parameters in the same order we had here. So I want to add 7 and maybe 45. We expect 52, and we try and run that. You can see our lambda function has ran as expected, and you can see that the lambda function only covers one line. So it is a simplified way of creating simple functions. Now that is all as far as functions are concerned. You can call functions from any point in your code, provided they were declared before that line. So if I've declared a function here, I cannot call it from. If I've declared a function on line 24, I cannot call it on line 22, but I can call it on any line below it. And I cannot call it from within itself, otherwise I'll get into a loop that doesn't seem to end. Now we are going to go to the next thing, that is called selection. Selection is when you have to make a decision. You have to make a decision based on the data you have, based on the results of a function. So we use if. The if, you have your test within the brackets. So for instance, you can say if 5 is greater than 4, then colon, what do you want that to do? Ensure that you have indented so that you can show that this block actually falls under the if. So if 5 is greater than 4, which is always going to be true. If that is true, we are going to output 5 is greater. Okay, and we can try and run that. So anytime 5 is always going to be okay. I've not printed, I've just typed. So print and close the brackets. So you can try and run that. So anytime we are going to have 5 is greater than 4. Now we can try and use maybe the height. Did we delete? We deleted the weight. We can try and use the age and compare if the age is greater than 18. So the age was 18. Is 18 greater than 18? No. 18 is equal to 18. But we can still try database, and we get the value of the object symbolized by age. And if the age is greater than 18, then it should print an adult. So that it only does one test. It tests whether it's greater than 18. So it has not printed anything because it's not greater than 18. What if we wanted to see if this is not true, then we use else. Else, what should happen? So they should print he's a child. So now here we have an alternative. If that is not true, then there is a case. Okay. Can the module. You can see it has said that he's a child because it's not greater than not greater than 18. But what if we want to add another test using the same variable? We can have it here. So now it's an else if. So if he's not greater than 18, then else if. So it's called an elif. An elif will have parameters. So else. So if he's not greater than 18, then we can have another test. So if it's greater than 11 or if it's greater than 12, then we can say he's a teenager. You can say that he is a teenager. You can say he's a teenager. So let's try that. And if he's not a teenager, then he's a child. Let's run that. You can see that he's a teenager. We can also have an if within an if. We can say if he's greater than 18, then it is very important to check if he is greater than 35. If he is greater than 35, then he is middle-aged. It is very important to indent to show that this block will happen after this test. If we do not do that, it will happen after this test. So the second if can even have an else. So this is called nested if. This is an if within an if. So this is the one who is supposed to be middle-aged. So we can see that if he happens to be between 18 and 35, say he is 30, he should be middle-aged. And you can see that is what it has output. We can have an if within an if. That is called nested if. And it is very important to remember indentation is everything. If you do not indent, you are going to get a lot of errors. If you indent wrongly, you are going to have some lines not being run as expected. So it is very important to observe indentation. It is very important to have orderly code. So that is all for today from the NACO Enterprise. So keep practicing until the next lecture 4. Okay, thank you. I can save. Then I can not be